Okay, good morning. And today we'll be working on building a horizontal wind tunnel and also working on a flow simulation on to show us how wind tunnel works. So, but before we begin, let us know more about wind tunnels. So, wind tunnels are tube-shaped facilities that allow engineers to move air over a vehicle as if it was flying. By by moving air around the object, the wind tunnel simulates the condition of that object in flight. So how does a wind tunnel work exactly? Well, wind tunnels usually have a powerful fan to move the air through the tubes. Um, the bigger the scale of the wind tunnel, the more powerful the fan you will need for the output flow. So if it's an industrial sized wind tunnel, you're gonna need a very powerful fan. So and wind tunnels are classified into low speed and high speed. They are further classified into a subsonic, which is 80% of the speed of sound, transonic, which is above the speed of sound, subsonic, which is up to 6 times the speed of sound, hypersonic, which is between 6 to 12 times the speed of sound, and hypervelocity, which is over 12 times the speed of sound. And wind tunnel are known to have mostly two major designs, which are the open return wind tunnel, which is mostly designed either vertically or horizontally, and it contains the contraction cone, the test section, the diffuser, the drive section, the settling chamber, and the closed return wind tunnel, which the most common shapes is more of a box configuration and has only the contraction cone, the test section, the diffuser, and the drive section. So, what makes the closed return wind tunnel so different from the open return wind tunnel is because of its shape. It's more of a box within a box. So, there is no outside flow of air coming within it. The airflow is mostly going around the wind tunnel without going out into the environment. So with this we will start our progression into building our wind tunnel, and we'll be focusing on the horizontal design of a wind tunnel. So we'll begin by starting a new model using SolidWorks. So while we have that loading, um okay, so we start by having our units. We'll be using inches. Yeah, so we'll be using inches, pounds, and seconds. So we change it to that. Then we will be creating our wind tunnel starting from the front view. Go to sketch. So what we are doing right now is we're starting by creating the settling chamber and the contraction cone as one. we'll make everything of equal length. And we extrude. So first of all, we make the measurement for our settling chamber right there, and then we move towards creating our contraction cone. Which is also 31. We'll make this a total of 18 inches. But to give us that slope, we'll be adding a degree of 30 inches, so 30 degrees I mean. So with this we have our contraction cone and settling chamber set. Then we'll move on to our test section. Okay, that's 10.22 degrees, so 10.22 inches. And with that we go back and extrude. Well, the test section is known to be the smallest area of the wind tunnel, but that's, yeah, actually the smallest component of the wind tunnel in dimensions. So we give it 15 inches. And we'll go on to build our diffuser. Also, we always want to make sure our squares are equal, because so when we change the dimension, all sides change with it. And we go on to build our diffuser. The diffuser is known to be the longest part of the wind tunnel. So we'll give it a nice 24 degrees, and we're going to be extruding it outwards in degrees. So we're going to reduce our number. It's always best for you to have like a side view when you are making your putting the degrees, because we don't want our diffuser to be the same height as our contraction cone. Although there are some designs that the diffuser is pretty much similar size as the contraction cone, but I prefer it to be smaller. Okay, so we have our diffuser and then our drive section, would which will have our fan embedded in it. Again, make everything equal. So for the fans, which is the our airflow outputs, you can pretty much have as much fans as you want. The more fans you have, the greater the power. So I will be having my design have two fans. So I'm just gonna set up using the measurements for of the fans I am going to be using. Each fan is about 3 inches wide, give or take. So I'll be putting it for 7.5 inches, just to have that that bit of enough space in case it's always good to have a bit of extra space in case you need to change something, or that's what I prefer. So now we have our contraction cone or solid model of it. Then we move on to creating a shell. Make it 1 inch, and this will go right through the entire model. So right there we have our inlet, which is the contraction cone, and our outlet, which is the diffuser leading to the drive section. So with this we move on to our simulation, which is the fun part of this. So first thing first, you should always save your work before you simulate. You can't pretty much go any way about it. It will make sure you simulate, so it will make sure you save it as practice practice 3. Okay, and we move on to simulation. So first thing first, we are going to use the tools to create leads for both ends of our wind tunnel. Okay, so we're gonna be selecting the surfaces of our shell, that 1 inch space that we left. Okay, so once we've created these lids, you want to check the geometry of our wind tunnel to make sure there's no um, air escape during simulation, and it would also show you if your dimensions are appropriate for this simulation. So we will do it internally. As you can see, our dimensions are okay. Then we go to do it externally. I prefer doing it that way. Okay, our geometry is also good over there. Then we're going to make our model transparent. Let me see. Okay. Well, okay. Just going to make this side transparent so we can better access inside of our wind tunnel. Then we move on to our simulation. Okay, we name our project. Um, we'll be using our SI units, changing our temperature to Celsius. Yes, every other thing is okay. We'll be using our pressure and stress as Pascal. We'll also be using internal and heat conduction in solids. If you are using a fan in your wind tunnel simulation, then I would recommend you also add rotation to it and apply it on the propellers of the fan. For our gases, we'll be going with air. And here is more of just selecting a building material that our wind tunnel is going to be made of. We'll go with we'll go with wood, timber. So back. This is good. This is good. Okay, so we will begin by um, editing our domain. We want to make sure our domain to give our domain extra space to make sure that our entire wind tunnel will be located in the wind tunnel in the domain. Okay, once that is done, we hide. Then we'll go to boundary conditions. Inlet velocity. We pick the end. That's why I made it transparent, because I wanted to select that end. And we change. Oh, okay, I forgot to do one thing. Units. Okay, so our velocity will be changed to feet per second. Just need to change that. Inlet velocity, we're going to go with 10 feet per second. So as you can see, these arrows symbolize air coming in our wind tunnel. And we go back to our insert boundary conditions. And we're going to go with environmental pressure. We have the temperature and atmospheric pressure. We're going to apply that to the end of our drive section. As you can see, the arrows are coming both in and out. Then we move on to our goals. Insert surface goal. We're going to go total pressure average from the inside. Renaming it as inlet pressure. Then surface goals again to the end, to the pressure average, and rename it to outlet pressure. Then we'll also compute our equation, which is inlet pressure minus outlet pressure. And we run our simulation. Then we move on to our cut plots, but before that we always make a section cut facing the right. This will help us visualize our flow much better. We start with cut plots, the right plane, and this is how the flow of our wind tunnel will proceed. And we also have the pressure readings. We'll hide that. Then we move on to surface plots. think. As we try that, use our faces and plot. So it's giving us the full scale of our wind tunnel and how the pressure will proceed, and so how the pressure and airflow will proceed. As you can see, we also have the density in fluid in kilo in kilogram per cubic meters. We hide that, and now we will be doing our flow trajectories. This will show us how the movement of our flow. We'll be increasing it to, let's say, 50 arrows. Oh, yes. Let's see. Let's see the right. Okay. Okay, so this is how our flow will take place. And if you need to, you can also play it. So as you can see, this is how the movement of our flow will begin and proceed to the end of the drive section. I'm just gonna stop and hide. Then if you ever need to increase your velocity, all you have to do is come here, select edit, and you can manipulate the speed of your inlet. So I hope this has been helpful, and I hope you enjoyed this video on the construction and simulation of a open return wind tunnel in a horizontal design. Thank you.